Hello, students, and welcome to our May 20th lesson. I apologize for that. Well, our objective today is to solve quadratics by using square roots. So we've got 2 work pages and kind of a fun exit ticket. For homework, I'd like you to do homework 7, solving quadratics by square roots. And there are some extra activities if you're finished. So let's just get right into the lesson. It's be a little bit of a long one today. So we're talking about solving quadratics by square roots. When we talk about doing this, we're talking about quadratic equations that are in the form of ax squared plus c equals 0. So we have no bx term, okay? Those are the kind that can be solved using square roots. So you have 2 basic steps, but they can be a little bit tricky. You're going to isolate x squared and then take the square root of both sides. And remember, when you do that, you need the plus and minus answer because for the example, -7 times -7 is 49, but so is +7 times +7. So we have our first example, x squared minus 49 equals 0. We'll add 49 to both sides so that we end up with x squared equals positive 49. And we'll talk about what happens if that ever becomes negative. So now what we want to do is we want to take the square root of both sides in order to isolate x squared and then isolate x. So remember, the square root of a perfect square is the actual number itself. What do I mean by that? The square root of x squared will be x. The square root of 49 will be 7. So if the square root of x squared is x, then x equals that plus or minus 7. And then we can put that in a set notation. X equals the set of all numbers such that x is -7 or +7. And that's the final answer. A couple little tricks you'll need to learn along the way. First of all, remember that a positive number always has 2 square roots. So let's look at some of these. Number 1, x squared minus 16 equals 0. We'll move 16 over, so we have x squared equals 16. And then when we take the square root of each side, we'll have x equals plus or minus 4. And we'll put that in set notation. Number 2, let's move 100 to the right. So x squared equals, this will now become a positive 100. And we'll take the square root of both of those, and x equals positive or negative 10. Again, we will write that in set notation. Okay, number 3, x squared plus 25 equals 0. We'll rewrite that as x squared equals, and we move 25 over, it's negative 25. Okay, if we try to take the square root of that we can't do. There's no such thing as this negative square root of a negative number. So our answer is the empty set. Number 4, x squared. When we subtract 7 from both sides, we will have x squared equals 81. We'll take the square root of both sides, and x equals that plus or minus 9. Number 5, x squared minus 5 equals negative 4. We're going to add 5 to both sides so that we have x squared equals 1. Take the square root of each side, and x equals plus or minus 1. And number 6, 6x squared equals 54. So treat it like you normally would. We're first going to isolate x squared, so we'll divide both sides by 6 to give us x squared equals 9. And we'll take the square root of both sides. Our paper is looking very Caribbean right now with these colors. I hope you're enjoying this. So x would equal plus or minus 3, because 3 is the square root of 9. So let's write that in set notation. Okay, moving on down the page. Why don't you try 7 through 10 yourself and then come back to the video and let's see how you did. Okay, number 7, we will divide both sides by -2 to give us x squared equals 49. And that becomes now positive 49. We'll take the square root of each side for x equals plus or minus 7. And number 8, we have 3/4 x squared equals 48. So we're going to multiply both sides by 4, which will give us 3x squared equals 8, 16, 24, 30, 48 times 4 is 192. And then we're just going to immediately divide that by 3 to give us, I'm going to go up, I'll do it down here, x squared equals 48. I'm sorry, x squared equals 64. And then we'll take the square root of each side, and x equals plus or minus 8. And in set notation, there we go. Okay, number 9, 3x squared minus 108 equals 0. So we're going to write it 3x squared equals positive 108. And we'll divide both sides by 3, which will give us 36. And we'll take the square root of each side. And x will equal plus or minus 6. And number 10, we'll rewrite this, 5x squared equals positive 45. And when we divide both sides by 5, we will have x squared equals 9. And we'll take the square root of x squared and of 9. And we'll have x equals plus or minus 3. Okay, so first page done. So let's move on to the next page. We have a few more to do. We have 6 more to do, and then we'll get to the irrational solutions. So number 11, 7x squared plus 66 equals 3. Let's move 66 over. We end up with 7x squared equals negative 63. And we divide by 7. And we have x squared equals negative 9. And the problem here, I hope you see it already, is the negative 9. That's an impossibility, so the answer is the empty set. Number 12. So for number 12, the first thing we'll do is move 3 over. So we will have 1/2 x squared equals 72. And then we will multiply both sides by 2 to give us x squared equals 144. We like that number. It's a nice perfect square. So we'll take the square root of each side. And we have x equals plus or minus 12. Number 13, let's move that 16 over. So we'll have 9x squared equals a positive 16. And then we'll divide by 9. So we're going to have a rational square root. So I'm going to work over here. We're going to have x squared equals 16 over 9. But we're okay with that, and here's why. We can take the square root of a rational number that has a perfect square in the numerator and in the denominator. So x would equal plus or minus the square root of 16 is 4, the square root of 9 is 3. So our set notation would be negative 4/3 and positive 4/3. And number 14, 25x squared plus 10 equals 46. We'll subtract 10 from each side, which will give us 25x squared equals 36. Then we'll divide by 25 to give us x squared equals 36 over 25. And we'll take the square root of each side. Remember, whatever we do to one side, we can do to the other. And x will now equal plus or minus the square root of 36 is 6. The square root of 25 is 5. In set notation, x equals the set of all numbers such that x would equal negative 6 over 5 and positive 6 over 5. And number 15, 5x squared minus 1 equals x squared. So if we subtract this 1x squared from both sides, we're going to end up with 4x squared minus 1 equals 0. And then we rewrite that. We move 1 over, so it would be 4x squared equals negative 1, or equals positive 1, excuse me. And then we divide by 4. And x squared equals 1/4. And that's okay. We can work with that. And x would equal plus or minus the square root of 1 is 1. The square root of 4 is 2. So that's plus or minus 1/2. And then we write it in set notation. Negative 1/2, positive 1/2. And number 16, 16x squared minus 34 equals 15. We'll move that 34 to the other side, which will give us 16. X squared equals, we add 34 to both sides. On the right side, we have 49. And then we divide by 16, and you see we have two perfect squares there. So we have x squared equals 49 over 16. And we'll take the square root of each side, and x will equal plus or minus 7 over 4. And we'll write that in set notation. Now, make it a little harder. We need a little bit, well, we have enough room, I think. So zeros of a parabola, the place where the parabola crosses the x-axis, they can be irrational. So we're going to solve these following quadratic equations, and we're instructed to write all of our answers in the simplest radical form, okay? Radical form. You haven't done a lot of that, so we're going to get some exposure to that. I really think I need to make this page a little bigger. Okay, I think that'll work for us. Okay, number 17, x squared minus 3 equals 0. So we'll move the 3 to the other side, and we have x squared equals 3. And when we go to take the square root of these two numbers, we can take the square root of x squared, and that's x, but we cannot take a square root of 3. So it will be plus or minus the square root of 3. So when we write our set notation answer, we will write it in this form: negative square root of 3, comma, positive square root of 3, close your squiggly brackets. So number 18 is similar. So we'll have x squared equals 8. And then we'll take the square root of each side. And now, in this case, the square root of x squared is 8, but we can think of x squared as x, the square root of x squared is x, but we can think of the 8 as the square root of 4, which is a perfect square, times the square root of 2. And the square root of 4 is 2, and remember our plus or minus. So the square root of 4 is 2, so we're going to have 2 times the square root of 2 as our final answer. So when we write it in set notation, we have positive and negative. So we'll start with negative 2 times the square root of 2, comma, and then the positive 2 times the square root of 2. Number 19, similar. X squared plus 8 equals 56. We'll subtract 8 from each side so that we have x squared equals 48. And we can think of 48, first of all, it's not a perfect square. So we're going to take the square root of each side, and the square root of x squared is x. But we can think of 48. Look for a perfect square. And we know that 48 is 16 times 3. And 16 is a perfect square. So we've got plus or minus the square root of 16 times the square root of 3. And the square root of 16 is 4. And that's our answer. We'll put it in set notation. And our work is done. So why don't you try the last few problems and come back to the video, and let's see how you do. Okay, number 20, x squared minus 15 equals 59. So let's move the 16 over. So we'll have x squared equals 75. Let me rewrite that a little more neatly. And let's get ready to take the square root of each side. So we're going to have x on the left side. And do you see that 25 times 3 there? So it's going to be plus or minus the square root of 25 times the square root of 3. And the square root of 25 is, of course, 5. And the square root of 3 is irrational. So we just write this in set notation. And our work is done. Okay, number 21, 2x minus 126 equals 0. So we will move 2x squared equals 126. We'll move that to the right side. And then we also need to divide by 2, which gives us x squared equals 63. I'm going to move that over so I leave enough room for my radical. So we'll take the square root of x squared and of 63. And on the left, we have x. On the right, we can think of 63 as 9 times 7. And the square root of 9 is, of course, 3. And square root of 7 is irrational. So our answer set includes negative 3 times the square root of 7 and positive 3 times the square root of 7. Okay, number 22. 8 minus 3x squared equals negative 22. We'll subtract x from both sides, and we get negative 3x squared equals negative 30. And we'll divide by negative 3, which gives us x squared equals 10. And we'll take the square root of x squared and 10. And we can't really do anything with 10. So x is going to equal plus or minus the square root of 10. So that's our final answer. Let's put that in set notation. And then we're on our last two problems. So number 23, negative x squared minus 10 equals 18. And we can move 10 over to the right, which gives us negative x squared equals 28. And we still have to divide by negative 1, right? Because we have a negative x squared. And when we do that, we have x squared equals negative 28. And if we try to isolate the x by taking the square root, what happens is we cannot have a square root of a negative number, so our answer is the empty set. And now we're on to our final problem of the day. 1/2 x squared minus 11 equals 25. So let's move the 11 over right at the start. So 1/2 x squared equals 25 plus 11 is 36. Let's multiply both sides of this equation by 2, which will give us x squared equals 72. Then we'll take the square root of both sides, which will give us x equals plus or minus, and let's think of 72 as 36 times 2. That's what we did right up here. So it would be the square root of 36 times the square root of 2, and the square root of 36 is 6, and the square root of 2 is irrational. We'll write that in set notation. And our work is done. You have a homework tonight. Let's remember to get to it. And remember always to practice, because with practice, you absolutely will be great. Great job.